Hey, good morning. Thanks for joining the webinar today. So let's give a few minutes for other attendees to join, and we'll probably kick off in another 5 odd minutes. Thanks. Okay, welcome everybody, and let's give probably a minute or two for others to join. Okay? Can you guys hear me? Can you give me a thumbs up? Okay, nice. We'll start in a minute. Let's give one odd minute to others. And as we go on, if anybody has any queries, just type in on your chat. I'll get them and I'll try to respond while I'm doing the presentation or once I'm done with the presentation. Otherwise, it's got fast. Okay, so let's get started, I think. Hopefully you can see my screen. So today, do webinar on, this webinar is all about cost optimization and specifically cost optimization with Qubole. And I'm Nagesh Reddy, Senior Solution Architect at Qubole. So I think nowadays we are with this recession being kind of on top of our head. Everybody is looking at optimizing their cost, making sure that they they reduce their overall spend and then save some bucks to make sure that they have a better runway, specifically the startups and other large startups, or let's say large organizations and others and startups who are making sure that they have a better runway in the future. So that has become kind of a very common practice nowadays. We will talk about cost optimization, how it can be achieved in Qubole, what tools Qubole provides in the ecosystem, so that those can help you in optimizing the cost. Now, before we kick off, I'd just like to kind of talk about Qubole, what Qubole is, and how Qubole kind of help customer basically. We have, and then I'll take you to basically what the Qubole architecture, how Qubole kind of works along with the big data lakes, your delta lakes, and other stuff. And then we will talk about how the clusters are spawned, how the ecosystem actually works in terms of what are the various components that we have, that is ETL, the data warehousing, and then we will talk about the cost optimization factor itself, and finally we will have a demo. So to kick off, one of the things Qubole was formed in 2011, and from there onwards, one of the things that Qubole has been good at is basically making sure that it understands the data and it can process a large sets of data, and then it can do a lot of AI/ML. But if you see the industry or the companies that Qubole is working with, like National Instruments, Canet, Expedia being one of the largest customers for us, Edelweiss, and these various customers, these are kind of leaders on their own in the industry. Yeah. Now, what they have been doing is basically learning from the past, or otherwise kind of doing the historical analysis or analytics using something like the usual visualization. Yeah, the Power BI is the yellow pens and the tableaus kind of thing, where you kind of analyze the data which is stored in your data warehouse or somewhere, and then you analyze that data. That's something learning from the past. And then understanding from the present, basically you do it the real-time analytics and kind of do more kind of a self-service and real-time analytics, basically, when you want to kind of understand what is going on right now. And then combining these two, you come up with something which is predicting the future, yeah, wherein you run your ML models, the AI models on the data which is on your past, and use them on the present data to make sure that you can predict something of your future, so which can actually make your now this is what I was talking about, that is learning from the past, which is business intelligence on historical data, and understanding the present, basically data exploration, analytics, and real-time and streaming data. And the third one is the predict the future, which is basically the AI/ML, which involves both, as I said, it involves the past data on which you will build your models, and the current data where you will kind of infer, using those AI/ML models, you will infer the data per se. Now, I'll just talk about, since I spoke about the industries that Qubole work with, the next stage is obviously what is Qubole doing it, and what about Qubole, where it is. So it is a data platform and open source pioneers. Basically, it started by guys who actually wrote the code for Hive and kind of started Hive. Okay, so it has a DNA of pretty much kind of an open source environment, but also this was one of the first few guys who made this software as a service for Hadoop ecosystem. Yeah, so this was one of the pioneers, and after that, all these other ecosystem came, some like Databricks and all those things, which were pretty late in after Qubole came into the market. Market adoption, Qubole is being used worldwide. It is there in North America, it's Europe, Asia Pacific, and EMEA and other regions as well. Customer first, and this is what we would be talking about, but what we have helped is customers save more than 600 million cumulatively since 2011. So that's a large amount of dollars that have been saved over the last 10 odd years. Proven in testing, we process exabytes of data every month, and we continuously improve our platform to make sure that it is kind of processing more and more data, as well as saving more dollars for the customers. Global presence, we have offices worldwide. We have North America, we have South America, we have APAC. We have 24/7 support, and that's one of the kind of forte where our support ecosystem is very strong in terms of professional services as well as the technical support. You can get started on a free test drive on any cloud of your choice, because Qubole is something which is cloud agnostic and it can run on any of the clouds of your employees. We have a pretty strong team of who have actually contributed to open source pretty aggressively. Now, Qubole is used by who? So Qubole is of course a data platform which allows you to process the data and do the analytics and build your AI and ML, correct? But for who can use Qubole per se, correct? So this is something that we have. Basically, it can be used by data engineers, all the personas which you can find in an organization, correct? So you have data engineers, you have business executives who can run their queries and all those stuff, data engineers who can write their ETL jobs to move the data from the source to destinations, and vice versa. And then data analysts and business users who can actually write simple SQL queries, or use our templatization of queries and get the output there itself. Data scientists to run their AML job. So as I said, it can cater to pretty much every person in an organization who deals with the data, and it enables you to make it self-service. Now again, I'll talk about, I'll go a bit in depth in why Qubole matters. What are the kind of what are the DNA parameters for Qubole? So one of the things that comes into first is basically it is simple, open, and secure. Yeah. When I say simple, it is, the first thing is it's UI driven. It's very simple. I think anybody who doesn't even know what Spark and Spark Resto and all those things, they can come onto the platform and just connect to their ecosystem and start using it. Okay, and that's what makes us kind of self-service, enable users like business users to come onto the platform and query the data. Then it is open and secure. As I started with saying that it's open. It's open, the reason being we use all the engines that we have, like Spark and Presto and Airflow and other, we have around 20 odd engines. All those engines are something which we pick from open source. So we actually take advantage from open source where everybody contributes to, but also kind of contribute to open source, make sure that whatever we kind of internally develop, that is helping the open source community as well. It's a secure platform. We make sure that the data is secured as well as the platform itself is secure. So to make sure that whatever is done on Qubole is stay there. We are HIPAA compliant. We have most of the compliance certifications that are available in North America and Europe, basically. So it's pretty much complies with that. We comply with data locality wherever we are kind of existing, because we have platforms which are North America, APAC, and other regions as well. Fast adoption of data lakes. We help companies or enterprises adopt the data lakes pretty fast, because one of the reasons, one of the issues that we have seen with enterprises is adoption of the data lake, because it's a complex thing, correct? The data is stored somewhere in the cloud in a file format, and or the data is stored in MS SQLs or basically MySQLs or any of the normal data warehouses, or something like a NoSQL databases. Yeah. To make value of all these data, it becomes very critical for an enterprise, correct? And for somebody like a business users who doesn't understand all these terminologies and all those things, for them it becomes overwhelming in terms of kind of querying that data. Now, what happens in most of the times is the business user raises a request using some kind of Jira, in that, okay, I need this data in an organization. And then it goes to a technical team who kind of starts uh, writing that Python script, or probably writing those queries, and then finally fetching that data in a CSV format or something, and then passing it back. This whole process actually takes a lot of time. Yeah, it takes, at times it takes weeks, at times it takes days. Yeah, but what Qubole helps you is making sure that, okay, it's self-service and you can start using it the moment it is onboarded. Out of the box tools for data science, data engineering, analytics. So we have various tools for all these personas, basically data science, where we have notebooks and other stuff, data engineering notebooks, and workspaces and analytics, where you can simply use APIs and other stuff to build your solutions. Near zero administration, that is one of the things that why Qubole was so is so liked, because if you see other competitors of Qubole, the administration cost is pretty high. You need a lot of administrators to manage. In Qubole's term, we have something like 200 is to 1. 200, when I say 200, 200, basically the number of nodes is to 1 administrator. That is what uh, we require, because most of the things are self-service. It's all UI driven. You can configure the cluster, you can manage the cluster, the SLAs and all those things. So something, once it is configured, it's pretty much up and running. So you need not kind of go and kind of monitor it, have a large DevOps teams to manage it. So that kind of makes sure that you have a lot of cost saving over there as well. Workload aware auto scaling, I'll talk about that in the next few slides, how it actually helps you kind of reduce the overall cost. We have a lot of insights in terms of reporting, and we also have something called as Cost Explorer, which helps you kind of understand what is the usage of the clusters, how it is being used, and it goes to the lower level of the job, correct, which kind of makes sure that, okay, you can understand why the job is taking time and other things. And by the way, we just have an open source tool, which is Spark Lens, which can be used. Of course, it can be used with Qubole, but you can definitely use it with simple Apache Spark as well, which gives you a lot of informational data in terms of wall clocks and other ecosystems in Spark, and then it will provide you why a particular job is kind of slowing down. What is it which is kind of slowing down? How you can tune your memory and other resources so that you save on your cost as well as run the jobs much faster. And along with that, from when we are talking about cost optimization, the other aspect is cloud provider specific optimizations, where we have read and write based optimization, let's say S3 based read or writes, or similarly with GCP, GCS based reads and write, and those kind of optimizations that we have built in to make sure that you save a lot again on the time the cluster is running. Reduce data lake cost by more than 50%. One is there is no hidden fees for us. It's simply pay as you go. There are no kind of tier-based charges or something like that. It's pretty straightforward. We don't have charges for per engine-based kind of thing. It is just use platform and then pay as you go. Automated cluster lifecycle management, intelligent spot management. I'll talk about that, and heterogeneous cluster management. Basically, where we use heterogeneous nodes to make sure the we use the instances optimally. Now, this is about architecture. I just want to take a few minutes to talk about the architecture here. Now, so this in Qubole, we have kind of 3 layers basically. Basically, the middle part, which is what we call as a Qubole control plane. The left side is basically Qubole data plane, and the right side is the consumption. Yeah. Now, in this case, Qubole control plane is something which is a software as a service that I was talking about, which have got all the tools, and it provides you the various the UI to configure all your clusters. Basically, the clusters or engines that I was talking about were Apache Spark. We have Hadoop, we have Presto, Hive, Airflow, and TensorFlow. Spark being mostly driven towards the ETL kind of processing, and then Hadoop we have legacy, along with Hive, and Hive we support Hive Asset as well with 3.1.1. Then we have Airflow, we have all these nice Spark and Hadoop and other things, but without Airflow, with the orchestration, it doesn't complete the story. Yeah? Because in any enterprise, for moving the data, you would require something like an Airflow to move the data, to orchestrate basically. Then we have Presto. All the data warehousing actually goes via Presto, wherein it once it is stored, and it can the large terabytes of data has to be consumed by the users. Yeah, and that is where kind of Presto comes into play. And one more example that I would like to give why Presto is very handy is basically when you go back, when it was basically, when I was talking about the various data sources, correct, the cloud-based data storage, and then MS SQLs, the MySQLs, and the various data sources, Presto comes very handy over there. It is a federated query engine. It can connect to your file-based storage, which is your object storage, and then your various other RDBMS or NoSQLs. It can connect to all of those and kind of create a data warehouse just out of the box, rather than kind of pulling all the data into a data lake. It can still connect to the various disparate data sources and get you the data. So it becomes very handy in an enterprise using Presto, and it provides you sub-milliseconds kind of responses as well. And Qubole has something which is Presto cache, which will make sure that okay, the responses are faster by 30 to 40% when you start using cache. Security, I already spoke about that, security, control, and governance. That's one of the pillars of Qubole, and we use something Apache Ranger on top of the usual governance for the data governance piece as well. And Apache Ranger is something which is an industry standard to make sure the data is governed properly and users get access to what they require. And then talking about the data plane. Now, again, when I spoke about security, one of the aspects of Qubole is we don't move the data from your VPC into Qubole environment per se. The data resides where it is. We spin up the clusters or engines, the engines that we spoke about here, Spark and Presto, on your VPCs. It will be on your compute. That is, let's suppose it is AWS, then it will be on the EC2 instances. It will be spinned up. It will access the data which is residing on the data lake, and if there are any warehouses or basically other ERP-based databases or any other things, you will be able to kind of consume in your VPC. So the data never leaves it. So it makes sure that okay, we are not controlling your data. The control of the data still lies with the customer per se. You will while configuring, you will provide access to the ecosystem or basically the cloud using IAM rules, and you can restrict it to just creating cluster, spinning up EC2, and minimum access so that you feel safe about it. And then finally, Qubole has something called as pipelines, which make sure that all your streaming jobs are taken care along with Spark streaming. Then the right side is about consumption, where you have users coming onto the UI, that is the Qubole platform. Then we have APIs which can be hooked up to your UIs, the usual dashboards that you might have. Correct? You can actually use APIs to query the data from Qubole and embed the data into your dashboards. Then we have SDKs. Basically, we have Python and Java-based SDKs, which you can embed in your code itself. If you want to trigger, orchestrate any jobs, any of those things, you can definitely do that. We have native connectors for Tableau, and apart from that, we have Yellowpen from Idelia family, and then Looker and all those others which you can connect via JDBC or DBC drivers. Now, coming to cost optimization, correct? Now, one of the aspects that there's something which is crucial, as I said, in at least in the today's world where we are kind of looking to optimize our spends. Yeah. Now, what are the challenges basically, if you look at it? Now, I think most of us might have realized, who have worked on the big data side of it, is costs can quickly escalate if it is not properly managed, because we start spinning up. I myself have seen that okay, there are clusters which are spinned up and it is not looked at after, and then when the bill comes up, it actually then you are in a shock. So I have been in an environment where the expectation was somewhere around 5K, $5,000, and the bill came up as $70,000, all because they were trying to optimize, they were trying to make sure the job runs much faster. But while doing that, they didn't kind of realize that they were using too many resources than what it was required. So that's the company took a big hit on that. The second one is basically unoptimized resource allocation and inefficient utilization. Basically, again, this is something that Qubole has kind of excelled in, to make sure that the resource allocation is perfect using something workload aware auto scaling that I will talk about, and make sure that there are no unnecessary instances which get spent up. Okay. Now again, there are other aspects in cost saving where you make sure that okay, there are no more clusters which are running 24/7, but they are running optimally. Those kind of things have to be taken into consideration. Manual scaling and lack of automation is something which is one of the things that escalates the cost pretty quickly. The reason is, again, when you scale up manually as a human being, you might not remember that okay, you have to scale down as well. Yeah, it's the lot of manual errors which you might do at any point of time, which might create a cost escalation scenario. And the scenario that I just spoke about was one of them, where it was a manual scaling and they kind of failed to kind of kill the job or kind of stop the instances and it kind of escalated, like I said, 20x. Now, what are the various strategies for cost optimization? Just what I spoke about, the challenge is something similar: right sizing the resources, selecting the appropriate instances, types and sizes based on the workload requirements. Now, what this means is basically making sure that we select the right instances and sizes. Basically, when you create an instance, create a cluster in AWS or GCS or wherever it is, a GCP, basically you select the right type of instances. If you are processing something which is very CPU intensive, select some instances which are more CPU intensive, like the C instances in case of AWS. Or if it is more memory intensive, you probably select something like an R based instances. So these type of selection actually make sure your job is executing much faster than what it would be, which will make sure that you spend less on your workloads. And definitely sizes, you have to make sure that okay, if it requires shuffle, then if you use many instances, then what will happen, because it will travel over the network. Yeah. So based on that, you select the size of instances as well. Now, that was just an example. If it is using shuffle, or let's suppose it is using cache-based memory, those kind of aspects will make sure that okay, what type of instances you will select. Maximum resource utilization, maximize your resource utilization that I was talking about, where you don't kind of spin up instances if those are not being used. Then automated scaling, Qubole is, as I said, is something which has excelled in this area, where it kind of dynamically adjusts the resources. It just doesn't scale up, but it scales down as well, as and when the kind of load comes back. Now, one of the other aspects is basically storage, because of course Qubole doesn't manage the storage, that is the data which is stored on S3, but effectively managing the storage becomes very important. The reason being because storage is also charged by the cloud vendors, and it escalates pretty. Now, how does Qubole help you? Correct. So one we spoke about is auto scaling, but intelligent auto scaling. Qubole has got much more intelligence in auto scaling rather than something which is just a CPU and memory based, which is more hardware driven. Correct. You figure out okay, there is a CPU which is hitting 100% use, just kind of scale up. Or if your memory is hitting 100%, or probably your memory, there is no more memory left, you spin up one more node. Correct. These are something which are common practice, but Qubole on top of that, it actually uses something called as workload aware auto scaling, which is the third point here, wherein it makes sure that the new instances doesn't spin up until and unless it sees that there is a reason to spin that new instance. Now, the new instance spinning actually takes somewhere between as low as 2 minutes in case of Qubole to, let's say, as high as 4 to 5 minutes in case if it is there are configurations and the instance size is pretty high, correct? So this 2 to 5 minutes that we spoke about from instance a node spinning up, that would be charged. Yeah, that would be charged by AWS. That would be charged by Qubole. Now, to make sure that we don't unnecessarily spin up that instances, we actually use something called as workload aware autoscaling, where we are aware of the workload that is running, let's say in Spark, and we see that, okay, does it worth kind of to spin up a new instance for that 2 to 5 minutes, or it will kind of can finish it in the existing configurations that we have, existing RAM and CPU and other things that we have. It can finish the job in probably considering that in the same time that the new nodes will spin up. Okay, that will kind of save you a lot of dollars in case of a large cluster and large volume of the data processing per se. And because this is high, we do very aggressive scale up and scale down, it will kind of impact you in the overall cost. And we have seen that, okay, users have saved a lot of money with this. Now, spot instance management, one of the other things that in cloud that you will find is basically spot instances used aggressively, because spot instances cost you somewhere around, let's say 70%, 80% less than what an on-demand instances would be. Now, it's here we are saying non-critical workloads, but I think if it is something which is, let's say, most of the, there are two type of jobs which you will run on Qubole, correct? You will run something like an ETL jobs and something which is more of ad hoc jobs like ad hoc queries, okay, and kind of analytic jobs, correct? These are something which are idempotent jobs which will not impact your data per se. So you can actually rerun these jobs without having any impact on your data per se. So you can use more of spot instances. What we have seen customers is using 100% of spot instances to make sure that they effectively use more of spot instances and save on cost. So using spot instances is very important to make sure that you save on cost. And additionally, Qubole has got a heterogeneous capability as well, wherein we don't even we don't just provide one spot instance and say that one type of spot instance and say that, okay, use only this. Let's say you're using an R5AX large. What we can do is we can provide R5AX large, but we can additionally provide, I'll show you it in the demo that you can provide different instances, and based on internal algorithms, it will figure out, okay, which of the instances least prone to preempted, and it will start using that. So that will kind of, again, that's something which is inbuilt in Qubole and which helps you save a lot of cost. Cost insights and recommendations. Qubole has something called as Cost Explorer. It has got cost-based analysis. There are a lot of things that we help customers in analyzing their cost. And using those statistics analysis, you can definitely bring down your overall cost. What is the best sizing? I think we spoke about this, all these components already. Right sizing your instances, utilization monitoring, you keep monitoring automation and auto scaling, spot instance usage, and data storage optimization. This is kind of extension to what I was talking earlier and how Qubole actually manages it. These are more from a best practices perspective. Okay, moving on. So what Qubole provides from a cost optimization perspective, correct? Now, Qubole has got auto scaling. So I'll show a demo quickly, but I'm just going to the slides here. In auto scaling perspective, what Qubole has got basically a concept of minimum worker nodes and maximum worker nodes, where it will start from minimum worker nodes and scale up to the maximum worker node based on, and it will kind of keep oscillating between these two as and when kind of the workload increases and decreases. Now there's a configuration basically where you can set the ideal cluster timeout, where you can set that customer cluster timeout, and if there are no jobs which are running on the cluster, it will kill the cluster. And you can definitely set this off as well if you are running something like 24/7, or you're running a data warehouse based cluster using Presto, you can turn that off. Then as we spoke about, we do have cluster timeouts, we do have kind of node timeout as well, where we kind of bring down the nodes, because we, as I said, that we have minimum nodes and we have the maximum nodes, correct? And as load increases, it actually spins up more nodes. It tries to bring down those nodes as the load kind of decreases. Now we have the ideal timeout here, the cooldown period basically for those nodes. If there are no jobs which are running on those nodes, and it can kind of move the jobs which are running on those nodes to other nodes, it will do that. And then it will remove that node from the cluster. Now you have on-demand based cooldown as well as for spot instances. Now, why do we have two cooldown periods, one for spot and one for on-demand? Yeah. The reason being, on-demand is something we should be more aggressive in terms of cooling down, because you can acquire them also pretty quickly. Whereas spot instances are something you can be a bit more lenient. The reason being, spot instances, acquiring the spot instances and kind of releasing it is acquiring the spot instances, which itself is something which is time consuming, or probably you might not get those spot instances again, correct? So you can be a bit lenient as compared to on demand. Again, the second reason being, spot will cost you much less than what on demand would be. I was talking about Cost Explorer. So we have we have built a tool which will help you make sure that you can explore your cost, what is the usage, how Qubole is kind of using, what are the type of instances, what each job is kind of using, what each cluster is using, and then you can kind of come up with, you can use those analysis and kind of optimize your cost as we go on. So there's one of the much like feature in Qubole. What it provides is basically Qubole usage related. One is it provides a total cost of ownership along with Qubole compute unit. Now, just to kind of let you know, Qubole compute unit is the unit level of charge that Qubole does. So let's suppose you spin up any of the instances, it will and you run it for an hour, it will associate with a Qubole compute unit, QCU, and that QCU will have a dollar value to it. And you can go to our website and see that what that dollar value for each of them. But QCU is the minimum unit of charge that. And then it's cost related. Basically, it provides you all the cost, which is cloud VMs that is being used. What is the cost for that? Are you using spot instances and other stuff? And along with that, what is the QCU? Insights, it's provide you spend reporting, optimization insights, and other stuff. So if you see the statement, basically that we use for marketing is allows you to monitor, manage, and optimize big data costs by providing granular visibility at workload set, job, cluster, and cluster instance level. So you can go to the level of job starting from cluster. Now, what do we track using CEP? Yeah? We do track at account level, at the aggregate account level. When you spin up something, when you start Qubole subscription, that is called as account. So you can track at account level what is that you're spending. You can go to tag levels. Tag levels are something which is done at every cluster that you spin up. You can actually tag it and say that, okay, you can give a tags, and based on that you can do analysis. Then you have cluster level. Of course, you can spin up. You can do analysis per cluster as well. Cluster instance level, which is more about what type of instances you are using in the cluster. You might be using on-demand instances, you might be using spot instances, and as I said, more memory-based instances or CPU-based, and all those different kind of instances. All those you can kind of do analysis using cluster instance level. Then finally, as I said, you can drill down to job level. You can go to the job level and see what that job is taking. Yeah, probably you might not be expect you might calculate an ROA on the job, that the job might not be relevant, but it might be taking a lot of dollars for you. User level, this is very important from a chargeback perspective. If the users are using too much, you can definitely look at that. If they are doing an efficient querying and all those things, why that is kind of costing so much. I'll show you a few quick slides of the visualization, how it looks like. So this is a TCO dashboard. This is the total spend This is where it says that, okay, this is 100 persons, and then it will talk about what is the spot expenditure, which is 5.4, and here the on-demand is 94.6. Now, if you see in this scenario, you clearly see that the spot instances are not used aggressively, and that's one of the reasons your cost might be pretty high. Yeah? And probably you would try to see improve your spot instances. And otherwise also this on-demand instances would be much higher and expensive. But still, in this case, it looks like that spot instances are not used effectively. Now it provides you what could be the projected, because this is, you can at any point of time you can get this value. So what is the projected, and the same thing actually sees that. Now it talks about how you can improve your expenditure and what would be the savings per se if you start using spot instances. So this actually provides you a nice view of overall spends, where you can save, and what would be your overall percentage if you start using more of what we recommend. And this is more about user level cost reporting, where you have all these users and the EC2 cost, the QCS, the one that I spoke about. Yeah, this is something which will be converted to dollar total EC2 cost, and it provides you a lot of cost based analysis, which can help you in terms of tuning it, making sure that user understand what they are using at the end of the day. Monitoring Showback, again, these are something which are, let's suppose you tag it, and then you tag the clusters, and based on that you can come up with the analysis of which of the departments are using, and you can go and charge back. Okay, so this I spoke about already: spend tracking, build ROI analysis, monitor Showback, justify the business cases, plan and budget, and optimize. So all these tools that we have provided, as I said, there are two aspects to it. One is basically how you configure it, but the other aspect is how you're using it, correct? What is the are you using it optimally or not? Using these analysis, you can go back and kind of fine tune your clusters and your workloads so that you can save on the cost. So all this basically helps you on that. Sorry, I'll just quickly cover these slides. Spend tracking and use case level basically talks about, let's suppose you have a Qubole BI base. So what is the spend that is happening over a period of time, how it is moving? Are there any abrupt changes? You can track that. There's a use case level. This use case for ROI evaluation, if you want to do, what is the overall cost for this, each command. Then this is a monitoring Showback if you want to kind of do it on a pie chart basis. So I will quickly go to the demo. Okay, so I have already logged into the Qubole, and Qubole has got various platforms, that is us.qubole, in.qubole, and eu.qubole, to make sure that we have secure. One is we take care of security, and second is we are compliant with the local laws. Yeah. As I was talking about that, the tool kind of provides access to the various personas. So we have Explore, Analyze, Workbench, which can be used by your data analyst, of course with a smart query. Data analysts, Workbench can be used by both your data analysts and data engineers. And then we have notebooks. Jupyter Notebook basically can be used by both data engineers and data scientists. And I was talking about pipelines, which makes your IoT kind of jobs much easier. That uses Spark streaming, which again can be used by engineering. We have inbuilt scheduler apart from the Airflow, which can be used. I'll talk about usage in a few seconds. But let me just configure one of the cluster and show you what I was talking about in the slides. Yeah. So we have the latest, which is 3.0 beta. You can label the clusters here. Now this is where I was talking about. This is a master node. This is a worker nodes, and this is something which is multiple worker node types. The heterogeneous nodes. And as I was saying, why this is important? This is important to make sure that when you capture the nodes, when you acquire the nodes, and you acquire spot instances, you try to acquire the spot instances which are least prone to be preempted, so that you can save on cost again. So it will provide you all the ratios, weightages as well, and you can kind of select. We can select 16 different type of instances to make sure that we get the optimal out of it. So this is master nodes, worker nodes. and heterogeneous nodes. And then the next configuration is about minimum worker nodes and the maximum worker nodes. So you can go up to 200, 300 nodes. So you can select probably as less as possible based on your requirement and where do you kind of see your workload to be maximum. Then we do have auto scaling on rather than auto scaling and upscaling on EBS volumes as well, where you can enable the EBS upscaling, which will again help you in terms of making sure that you start low, but you can kind of keep on going higher. Let's say you're using a data warehouse based cluster, then probably you might need more of EBS volume as well. But since it allows you to upscale, you might not start with something which is very heavy. So that would take care of it. This is what I was talking about, disable automatic cluster termination. If you don't want the cluster to be terminated, you can enable this checkbox, and otherwise you can have a cluster timeout. I'll move to composition. Basically, composition is all about what do you want your instances to be. Yeah? You can have all of the master nodes to be spot instances, the minimum node to be spot instances, and the auto scaling node also to be spot instances, or the instances that you want. But usually the master nodes are something on demand so that you don't lose those instances. The minimum nodes are also on demand, which are wherein you say that, okay, you don't lose those instances. But as I said, if you have clusters or if you have rather than clusters jobs which are idempotent and which can be rerun without losing any of the data, you can definitely go and make this all on spot instances to save on cost. Then you have fallback on demand. Let's suppose you are not able to acquire spot instances, you can definitely fall back to on demand instances. Now these are the weightage for spot nodes and maximum nodes, the price that you want, spot node percentage. So when auto scaling nodes, these are the auto scaling nodes, you can tell, okay, I need 50% spot and 50% on demand, or you can simply say that, okay, I am good with 100% spot. It automatically removes the on demand instances. This is the bidding price for those spot instances and the request timeout. And basically, if you want to have nodes to select it. Advanced configuration is all about which VPC you want to configure. As I said, the data is not moved out of your VPC. The data still stays in your VPC. So it's about configuration, the VPC and subnets that you want if you want to provide elastic IP address and all those stuff. But yeah, talking about cost, as I said, these becomes very important where master node, worker nodes, and multiple worker node types, as well as composition, how you want to use spot instances and on-demand instances. And the other clusters that we have are something similar. We have various clusters like Spark Streaming, we have Presto. The only difference between these, most of the clusters, in fact, all the clusters, Spark Streaming, Presto, all of them work on the same principle. Apart from Presto, wherein I say that you should try to enable Rubik's cache so that it will make sure that the queries are faster by 30% and this is enabling the Rubik's cache, which will save you again in terms of cost optimization. It will save you on the time it takes to run a job. So that's configuring clusters, how Qubole actually helps you in kind of cost optimization. I'm quickly going to, so we have got one is Cost Explorer, the other one is simply usage, where you can track the usage. So this is one of those reports. Basically, you can actually go to the commands. You can execute various commands in Qubole, and you can select the date ranges. You can select the cluster if you want, which cluster that you want to kind of query. And you will see the analysis here. The cluster ID is basically the label of the clusters. If there are any EC2 tags, so it tells you all of these are kind of on-demand instances, and there are no spot instances which are used. The start time, end time, what is the duration? If there are any QC which is charged, what is the reason that the cluster got terminated? Is because of inactivity or user kind of stopped it. All these analysis kind of helps you in terms of making sure that you optimize on your cost. And you can go to commands as well, canonical high, node versus time remote, and the various things that you can get out of this. I'll go to the status here, wherein you can see various what type of commands that were executed, correct? That you can analyze from here. job instance status and other stuff. So you get a lot of insights and other things, not only from the Cost Explorer, but also from the user stats that we have. I'll stop here. I'll take questions if there are any. I'll stop sharing and I'll take questions basically. Now I have one question here which says that, okay, can we use an heterogeneous instance where you have different type of instances, let's say R5 and C5? Okay, so here it's talking about having heterogeneous instances, but not of the same family, but different family like R and M or R and C. Yes, you can have it. It just depends that how you want to configure. But ideally, it would be great if you have configurations of the same family, because then it can calculate it much more easier. Okay, let me see what other questions that we have. Okay, another question is basically how do you basically how the caching helps in case of Rubik's. As I said earlier, a Rubik's cache will make sure that you save cost by at least by 30% odd. It makes sure that the data is saved locally, and Rubik's cache is something which is developed by Qubole and kind of donated. It's saved locally, and when you rerun the query, it will try to first see in the cache. If it is not, then it will go and fetch the data from S3 and process the data. So it will save a lot of time in terms of, say, fetching the data from S3 and processing it. So that is where it saves the cost. Okay, let's see what other queries we have. Is this Cost Explorer something which is out of the box free? It is. We do allow Cost Explorer for our enterprise users, and for all the enterprise users, we have it free. Okay, I'm just waiting for any other queries. Okay, I see one more query wherein it says that, do you support Delta Lake? Yes, Qubole does support Delta Lake, and we do also support Hive ORC or Hive Asset Person. Okay, let's give it a minute or two more. Okay, since there are no more queries, thank you everyone for joining the call today, the webinar today, and hope you have enjoyed it. Thanks a lot. Bye.